Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amar Danish bin Zahrin and my trade number DF220164 and I am going to talk about the introduction. Differentiation and integration are two fundamental concepts in calculus. Both of them are complementary. The outcome of integrating a function's derivative is the original function. Simply said, the integration is opposite of differentiation, which is why it is often called as antiderivative. Differentiation is a process of finding the rate of change of a function at a point. The derivative of a function is a new function that tells us how much the original function is changing at a point, while integrating is the process of finding the area under the curve of a function. The integral of a function is a new function that shows the total area under the curve of the original function. The determination of a function's differentiation and integration at a specific values and within a specific range of finite limit is possible. Integration with stated limit is known as definite integration, while the general integration without stated limit are called indefinite integration. In many different branches of mathematics, science, and engineering, differentiation and integration are applied. They are utilized, for instance, to research the movement of things, the flow of fluids, the operation of electrical circuits, and many more.
Okay, Assalamualaikum. My name is Wan Alif Najmin and I'm going to present the problem statement for the project. Okay, for this project we got two problem that given. First is the traffic data collection around the Parit Raja. For this problem, first we need to plot two graphs, which is volume versus time and the average speed versus time. Second is determine the whether it is increasing, decreasing or constant of the interval. And then we need to calculate the rate of change for every 15-minute intervals. And then we need to find the relative maximum and minimum number and the absolute maximum and minimum number. This calculation will be further explained by my groupmate next time. Okay, next is the problem 2. Problem 2 is the experimental testing of the concrete prism under flexural load. First, we need to plot a graph of flexural strength in kilonewton versus the deflection in meter for the purpose of the finding the energy of the concrete. Next is portioning area under the graph for the easier manual calculation of the area under the graph. And then the polynomial trade line to be plotted linearly for estimating the function and integrating the function based on the limit of the graph. Lastly, we need to make a comparison of result obtained between both of area calculation method that we use two method, and then we need to compare the result for both method.
Okay, so this is a solution for problem 1. The following is the traffic data in front of SMK's regarding from 5 p.m. to 7 p.m., which is peak time, given the volume of the vehicle and the average speed of the car for every 15 minutes. Okay, so for the first question, we need to plot a graph based on the data given, then find an interval that is increasing, decreasing, or constant. This is the volume versus time graph and the average speed versus time that we obtain based on the data. Based on the volume versus time graph, we found that at minute 15 to 30, 45 to 60, and 105 to 120 has an increasing interval, and the rest of the minutes experience a decreasing interval. Meanwhile, based on speed average versus time graph, interval increase at minutes 30 to 40, 60 to 75, and 90 to 105, and the remaining minutes experience interval decreasing. Okay, next, we need to find the rate of change for each 15 minutes interval. To calculate the rate of change, we can use the formula y minus y1 equal to m times x minus x1. Or we can simplify to m is equal to y minus y1 divided by x minus x1, which can also be referred to as the change on the y-axis divided by the rate of change on the x-axis. So for an example, to find the rate of change for average speed versus time, m is equal to 73.8 minus 80.9 divided by 30 minus 15. Then we will get negative 0.473 for m1. Okay, so after computing the rate of change for both graphs, then we can determine the relative maximum and relative minimum, as well as the absolute maximum number and absolute minimum number for both graphs. So for volume versus time, the relative maximum is at 283 at minutes 30 and 326 at minutes 60. Meanwhile, the relative minimum is at 271 at minute 45 and 287 at minutes 105. Therefore, the absolute maximum number is 326 at minute 60 and the absolute minimum number is at 271.45 for volume versus time. Then, average speed versus time, the relative maximum is at 72.8 at 75 minutes and 74.6 at minutes 105. Meanwhile, the relative minimum for average speed versus time is at 73.8 at minute 30 and 69.5 at minute 60. So the absolute maximum number is 74.6 at minute 105 and the absolute minimum number is at 73.8 at minute 30 for average speed versus time. Okay, for the last question, we are required to plot the graph of cumulative volume versus time, and then from the graph obtained, we need to calculate the rate of change for each 15 minutes intervals and investigate the average rate of change of the graph. So as you can see right here, this is our graph obtained from the data of cumulative volume versus time. Then after that, we are computing the rate of change by using the same method as before, which is m is equal to y minus y1 divided by x minus x1. Then we will get the answer for rate of change for each 15 minutes interval for cumulative volume versus time. Then to find the average rate of change, we just need to add all the answers that have been calculated from m1 up to m7 and divide by 7. So we will get the answer for average rate of change is 16.752.
Hi, my name is Muhammad Firdaus Amin bin Zulkifli. I will be explaining for the solution of problem 2, which is related to application of integration. As we know, we have about 1000 of data of MOTA, which is flexural strength and deflection. The data of flexural strength originally in form of Newton and changed to kilonewton, while for the deflection originally from millimeter changed to meter. Based on the data obtained, a graph of flexural strength versus deflection can be plotted to analyze the area under the curve versus deflection. It can be plotted to analyze the area under the curve, which is technically the energy of the motor. After plotted the graph, the area under the curve can be calculated using two methods, which is manual calculation method and polynomial trendline method. At first method, we have manual calculation method of calculating area under the graph. Based on this method, the area under the curve can be manually separated approximately by using the shape as triangular and trapezoidal. The separation were taken as approximately as the curve is not in the straight line. Then, each of the area can be calculated and totaled up to get the total area, which is 0.00269. Furthermore, we have polynomial trendline method. This method basically using trend line, which is straight and linear along the curve of the graph. As the trend line were drawn, a function can be obtained. Thus, from the function, we can integrate definitely using limit from starting of the graph to the end of the graph. Hence, an area which is energy can be obtained, which is about 0.0284. Lastly, we can move on to the comparison between both area calculation method. As it can be seen, the result between both methods are slightly different. Although the results are different, it is still close to each other, meaning that both of the calculation method are correct with a little bit of sensitivity error. So that's all for the application of integration for solution 2.
The knowledge of derivative is important to us because it widely used in engineering, human life, and many fields. As conclusion, all the concepts allow us to determine the relationship of one changing variable with respect to the other. Meanwhile, as engineers, we are exposed to the variety of geometrical shapes like rectangle, circle, and so on. And we need to find the area of each of them. However, when we need to find the area under curve or volume of axis in the graph, we might come across some problem. From that, the application of integration applied to solve it. As conclusion, from the study, we used to analyze ability and understanding both conceptual in the application of differentiation and application of integration engineering. The idea is to solve the problem given with a suitable method and express it in calculation to get the results.